less users, because that is being taken care by virtual machine. Virtual machine will take some resources like CPU resources, memory resources, and then virtual machine will give that resources to your bytecodes, to your application, so that we can run more number of applications. Okay, more number of application we can run, and then so this is why we are using Java most of the time, and then this is why we are having J2ME as a small part of Java, so which is being used in cell phones, smart cards, personal organizations, and laptops. So it's a Java-based platform for such customizations. So the customization I already told you, like all those resources needed, and it's a Java-based platform. Okay, and who have developed this J2ME? So previously it's been developed by Sun Microsystems. So Sun Microsystems is the only one organization who have developed Java. First Java language is being developed by, first Java version is being developed by Sun Microsystems, and then later on, then vendor like Nokia, they took over on J2ME, and then they developed something in J2ME, and then contributed to J2ME also. And this is how why we're reading, and what is your Java J2ME, and who have developed this J2ME. So what is Java? So as I already told you, Java is like write once and run anywhere. That means like you can write that application in one host machine, and then you can run anywhere. Okay, run anywhere means if you have the virtual machine, you can run in any processor, in any architecture. Okay, you just need Java virtual machine as the abstraction layer on operating system, on OS, on your OS, whatever the OS you're using. Like if you're using Windows, am I not audible? Like someone's talking about voice is not clear. I think so it's clear only. Am I audible? Okay, it's fine then. Yeah, we will continue with the. I think it's audible and clear. We will continue further. Okay. Okay. So yeah, so we'll continue with the. So J2ME is like you can write once and run anywhere. Okay. So okay. So different devices here the reason is like we have different devices have different requirements. Okay, so those devices doesn't have the same environment as regular computers, like desktop standard desktops, and the devices like which have limited memory. Okay, your handheld devices like your mobile devices, which will have limited memory, and they will have less CPU power. CPU, that frequency will be less, and there will small screen sizes. Alternative input methods will be there. So they need some kind of one platform solution. So that one platform solution is your J2ME, to create your application like web server applications, to create your video game applications. So users and developers also want flexibility. They also want flexibility so that they can write their application in any what they want to do with your application. So looking into these constraints like Java standard edition of Java, or your enterprise edition of Java, which we are actually using to create your application on desktops. Okay, the same thing is on mobile applications. So this J2ME is for creating applications for mobile platforms. Like if you want to create your applications for your handheld devices, your mobile phones, you need to use this J2ME. So Sun have decided to develop a new special edition of Java, that is J2ME, that is called Java editions. Okay. So what are the different forms of J2ME Java we have? So Java 2 platform is split into three editions. First of all, it's a Java 2 standard edition. So basically, it is being used in desktop-based servers. Okay. So desktop-based servers applications, desktop-based applications actually. So desktop-based application will use J2SE, and then server-based applications will use J2EE, that is your Java 2 Enterprise Edition. And then for handheld and embedded devices which have less memory and less CPU power frequency, so we will be using J2ME. Okay. So each edition provides a complete environment. So if you see J2AC, it will provide a complete environment, runtime environment actually, to run your Java-based applications, including Java virtual machine. You need Java virtual machine every time, like in the case of desktop, in the case of server, in the case of handheld, everywhere you need Java virtual machine. But those Java virtual machines are also specific. If you're using for desktop, that Java virtual machine will be different. If you're using for server, that will be different, and for J2ME, it will be different. We will be looking into the later slides what all Java machines we have and how we use in these applications. Because the Java virtual machine also provide runtime classes here. So we need APIs, right? So who will provide the APIs? We will be having defined classes. So at the runtime, if I need some class, at the runtime, if I need some APIs, we need runtime classes for that. So that will be by your Java virtual machine environment, JVM environment. Okay. So what separates one edition from another? It's like a set of libraries. So from one set to another, what being changes is your set of libraries only. If you're changing libraries, if you're adding some libraries, new libraries, or if you're deleting some new libraries or deleting some library, so that is the only change. Okay, because here Java basically use classes. You know, class. What is class? Class will have some defined interfaces, some defined methods, some defined functions, you can say. Okay, so if we have the object of that class, we can actually call that function or method within that class. It will provide a kind of interface. So if we have the object, we can actually run the APIs, run the methods which are being provided by the classes. And then group of classes is called a package. So in case of Java, we use, like, we will say, well, when we say we are importing package, that means we are actually importing the different number of classes. So okay, so that is how it works actually. So you can think of J2ME as a J2AC, that's already told you, and then J2AC is a subset of J2. Now this is a big picture of your Java. So you have J2EE as Enterprise Edition, J2SE as the Standard Edition, and then we something have like CDC, CLDC APIs, then Java Card APIs. We will also study. We will also look into Java Card APIs or Java Card technology in the next session today only. But so Java Card is also a form of it's a profile. It's a kind of application APIs, group of APIs, which for that we are using different virtual machine. So that is your card VM, card virtual machine. Okay. So for your J2ME is basically consist of your the CLD APIs. You can see this CLDC and CDC. CDC and CLDC are both part of J2ME. Okay, J2E is different, J2SE is different, CDC, CLDC APIs are different. Okay, so these are basically your configurations. So what kind of devices you are using? We will see what is CDC and CLDC in next coming slides. And above that APIs, we are going to use some profiles like MID profile, PDA profile. So basically, it's a profile means some set of APIs for specific task. Like if I want to write some application for setup box, we will be having setup profile. Okay, for TV applications, like we have TV like that. Okay, so it depends like what kind of application we are actually writing. We are writing application for a setup box. We are writing application for a TV, or we are writing application for some networking. So the profile will be right as of now. We will be discussing this whole big picture in slides. You can ask me any questions if you have. Okay, so J2ME. Okay, so at the heart of Java 2 Micro Edition, there are three concepts. So what are the three concepts? Like we have configurations, profiles, and optional packages. As I already told you, configuration means that that CDC and CLDC I was talking about, those are configurations actually. And then above that we have profiles. Profiles is regard to the applications. Okay. And then configuration profiles, and we have some optional packages. Optional packages means if we want some optional packages will contain the classes, right? And then classes will contain again the methods and functions. If we want another functionality, we can add optional packages related to those classes, and then we can write. So you can't write a J2ME application without understanding these concepts, okay? Because they determine the features of Java that you can use, which application programming interfaces APIs are available, and how your applications are packaged. So to write your J2ME application, you need to understand for what configurations you're writing, and then for what profile you want to use it on this J2ME application, and then if you whether you need optional packages or not. Okay, so this is how it works. So at the bottom side, you have your host operating system. So above that, we have your Java virtual machine, and then your Java language will be running on your Java virtual machine. So we will be having J2ME libraries here in this case, and J2ME libraries above that, we will be having J2ME profile. So up to J2ME lab Java virtual machine, your language, your libraries, and your VM all is a part of your configuration. Okay, all is a part of your configuration, and then above that we have J2ME profile. Okay, so what is a profile? A profile is a collection of Java classes, as I already told you, selected from one or more Java cores, extensions, vertical APIs, and then classes are chosen to provide a complete solution of a specific vertical market. Vertical market in the sense like you are writing your application for your TV domain or your setup domain, so that is your vertical domain. So you will have different profiles to write different kinds of applications. So different vertical market solutions. And then configuration, what this configuration is, like it's a subset of Java core API Java platform. Okay, you want to run your profile in some configurations. So configuration is based to your device and to your related to your device power, or your device memory cost, and all those things actually. Because some like setup box, the application written for setup box, you cannot write your you cannot run your application on your desktop, right? So for desktop, you will be having different runtime environment. Okay, so that runtime environment is nothing, is a configuration of your device. Okay, so this is what actually. Yeah, so we will have configuration. What it all means is like configuration, profile, and optional packages should be chosen. Yeah. So that is what J2ME application is all about. So a configuration is a complete Java runtime. As I already told you, Java virtual machine will be having, which will be executing Java set of core Java runtime classes, and then interface to the underlying systems. So underlying operating system will be having some interfaces to talk to that. So what is the profile? The profile adds classes to a configuration to fill in missing functionalities or to support specific uses of a device. Specific uses of a device, that means like I'm using setup box, so functionality related to setup box. Are you using TV profile or functionality related to TV profile? Okay, so it will fill some missing functionality also. And optional packages are a set of APIs that are support additionally. If you want some common behaviors and you have some support, you want to support some additional packages, you can use it. Like if you want some Bluetooth networking, so you will include some Bluetooth optional packages. Okay, JDBC is your Java database connection. Like if you want some database queries, you can have your JDBC optional package included in your application. So now here comes with the, we have two basic configurations. So and CLDC. So what is CDC? CDC is your connected configuration. Connected device configuration means the configuration for the devices which are basically connected to your power, which are basically connected to your continuous power, like AC supply. Suppose setup box is there, right? Setup box will not be having any battery stuff, right? It will be connected to your continuous power. So in that case, we don't we are not worried about power consumptions, we are not worried about, and also some memory will be more as compared to your CLDC. We will see what is CLDC. CLDC is connected limited device configuration. Limited means we have limited over there. So limited means we will having limited power, limited memory, limited processing power, like this. So the example for that CLDC you can give, those configuration can be run on your handheld devices, on your mobile phones. Like if you are using a mobile phone, you need to use CLDC configuration for that. Okay, so CDC will be having less memory, less processor, less power. Okay, 2 MB or more memory for Java platform. So, yeah, so CDC will be as compared to CLDC will have more these things: processor, memory, and power. So now this is the CLDC. As you just now see, in CLDC we have connected limited device configuration. Limited device configuration examples, you can see examples like your mobile phones, your PDAs, your personal digital assistants, okay, your handheld devices, your smartphones. So those will come into the configuration of connected limited device configurations. That will be having around 512 KB of total memory, 16 to 32-bit processors, low power consumptions because we are not connected to the power. It will be operating on the battery power, connected with the limited bandwidth, and then some classes like java.lang, java.io, input outputs, utilities like these will be included. And limited VM. Okay, limited VM means limited virtual machine also we're going to use here. So because of that, we are using KVM here. KVM is your kilobytes virtual machines. That will be less powerful than your virtual machines. Okay, so the Java virtual machine JVM you are using, that is more powerful than KVM because in KVM we need less memory, we need less power. So we have this KVM here. So this is what KVM is. We will go see. Find a new set for input output called generic connection framework, and then since the CDC is a superset of CLDC, the CDC is a superset of CLDC. Okay, because CLDC is small and CDC is large. It includes GCF also. Okay, so yeah. So these are the major two configurations we use here, CDC and CLDC. So CDC based make development, we are going to use like in like APIs we are going to use in the low end cases here. Okay, and the CLDC we are basically use for limited where we have limited power, limited memory. So these kind of profiles we'll be using. So the profile, depending upon the CDC and CLDC configuration, will be different also. So these are some profiles which I was talking about, like above configuration you have profiles. So one profile like mobile information device profile, MIDP profile, it is CLDC based profile, which is being used for running applications like on cell phones, your interactive gadgets, which will have small screens and wireless HTTP connection will be there, and limited memory will be there. So this is one MIDP profile. Okay. Similarly, we have personal digital assistant profile. So PDAs, like you have PDA, your devices you have. For that, we are going to use different profiles. So all these profiles are CLDC based. Okay. Then we have foundation profile, which is CDC based. Okay. Then we have personal basis profile and personal profile, which are again CDC based. So now you know the difference between CDC and CLDC configuration, and you also know if we are using CLDC configuration, we will be using different profile, and if we are using CDC, we are going to use different profiles, depending upon what device you are actually focusing on to make your applications, to develop your applications. So in this J2ME, we are going to use MIDP profile. So in MIDP profile, we basically design like midlets, applets in your Java. Similarly, for MIDP profile, we will create some midlets. It's a small application which will be using a specified set of APIs, and that API is from your classes, and then we need some packages, right? So MIDP profile is dynamic and it is secured. It is very optimized. It will provide your graphical and network applications facility. And then MIDP specification was designed through Java Community Process (JCP) by players like by some companies. This profile is being developed. It's like a version of these companies who have developed this MIDP profile to actually create an application on CLDC mobiles, CLDC configuration mobiles. Okay, CLDC configuration devices. So these are the companies like Motorola, Nokia, Ericsson, and Symbians. These come together and will create an MIDP profiles. Any questions regarding CLDC, CDC, or regarding profiles as of now? Because these are the important concepts, like when we are going to go in the J2ME and J2SE and these things. So first of all, you should know about these things, and then only we'll go and see some examples of MIDP profiles, some applications. So MIDP's this profile is being it's being used on mobiles, mobile information devices. It will be targeted for some specific class of devices. Okay, so where we have enough memory to run MIDP applications, and the display will have like 96 by 56 pixels or monochrome displays. And then keyboard and keypad and keyboard touch screen you can connect, and you can have also you can have your wireless network connectivity capability. Those applications can use those facilities. So there are two versions of MIDP profile. One is 1.0 and one is 2.0. 1.0 is the original specification which provides the application functionality for mobile applications with basic user interface. So when it came first time it will have some user interface only and some network securities features. And then in the revised version, we have some new enhanced features like multimedia, like game functionality. All those are being provided, and end-to-end security. All those are being provided into the next versions of MIDP profile, MIDP 2.0 profile. So MIDP profile does not run the regular Java fashion. So your profile, this profile we're basically using for mobile devices, and that is using which configuration? CLDC configurations. So it will not go, this application is not going to run in a similar fashion as you're going to run your Java application, main and system.exit, like those APIs, because that interface is totally different for these applications. So instead we use midlet applications here. As I already told you, we will be using midlet applications, okay, which are sub to java.microaddition.midlet.midlet. This is the one package. So from this package we are going to import these classes, subclasses. Okay, java.microaddition.midlet.midlet. So when we enable download options here. So this is the one package, and we are going to use subclasses from this package. So midlet class allows the application management software to control the midlets, and then we can also retrieve properties from the application descriptors and notify and request state changes. So we'll see how it actually works, your midlet application works. So if we are not going to use main and system.ext, these APIs, what we're going to use and how we're going to execute our midlet applications on CLDC profile, on CLDC configurations, we're going to see that. So this is actually, it works, midlets. So you will be having some functions like start app. Start app, that method will be provided in some package which we are actually importing from your I showed you that micro addition, okay, the JavaX micro addition midlet.midlet. So that will include some subclasses. So from that we will have some methods like start app, pause app, destroy app. These methods will be called. So if you want to start your application, you will be calling start app function. If you want to destroy it, you will just call destroy app. And you want to pause it, your application, you just call pause app. So it's a very basic application and very user-friendly interface actually. So just using like these, like start app, pause app, destroy app, and you can actually create your midlet applications. Okay. So extending classes, the main classes of application. These are the functions. If you want to notify your you can actually package your midlet applications together into a midlet suite, which is composed of like Java Kaved. We can create jar files. We can create a Java application descriptor files. So those files and then we can actually upload to the machine in order to run the applications. So if you want to include or if you want to pack you have to create a jar kind of these files, jar file or JD files, and then you can actually eventually upload those files in your machine in order to run the applications. So J2ME is all about your configuration plus profile. So if you know your configuration, if you know your profile, you can actually go forward and write your application looking into the APIs which are actually being provided from your profile. So different profiles, different APIs. So today there are nearly 40 J2ME related specifications at various stages in JC, and many of these specifications define optional packages instead of configuration and profiles. So there is one more concept, that is optional packages. So why we need optional packages? And optional packages is also a set of APIs, but unlike a profile does not define a complete application environment. Okay. An optional package is always used in conjunction with a configuration or a profile. It extends the runtime environment to support device capabilities that are not universal enough to be defined as part of profile. Yeah. So examples like for optional packages, like I already told you one example, the Bluetooth. If you want to use Bluetooth, you need to add your Bluetooth optional package. If you want to use wireless messaging APIs, you need to include. If you want to use remote application invocation, RMI, we will discuss about RMI. Remote method invocation is like you have server and you have client. On server, you have created some objects. Okay, you have created some objects, and on your host, if you want the methods, okay, if from the host, if you want to access those methods, you will just take a reference of those objects from the server, and you can directly call those functions which are running on your server. So it's a kind of remote method invocation. Like you are actually invoking your methods remotely on which is running actually on your server. So this is how your Java remote method invocations also works here. So there are some companies which have created your Java 2ME suites, and VM, which is being developed by your Sun Microsystems, your Flowbyte virtual machine, which is specifically designed for J2ME to run J2ME profiles. Okay, so this is again the same big picture. These things, and then you've discussed about CDC and then CLDC APIs and mid APIs, mid profiles, mobile independent device. That profile is there. So where we are creating actually midlets applications. The midlet application we are going to use mid profile we are going to use. So APIs which are being provided by the mid profiles. On those midlets we can actually run on our mobiles or our handheld devices like this. So this is the summary of your Java 2 Micro Edition. It is a small footprint version of Java for resource constrained devices. Resource constrained devices which will have less than 512 KB of RAM, your 64 kilobytes of Java heap memory, which we're using for dynamic memory educations. So it's less. It is about 64 kilobytes. And some profiles like CLDC profile, which is being required for J2ME. It's because it's a minimum required compute of complement of Java technology. And then some profiles. Okay. So this is the summary of this session. Now, how we are going to install our J2ME? So we'll see in the installation. So these are some requirements where you can actually download our Java 2 standard edition SDKs. So even if you are using J2ME, you need standard edition SDKs. Okay, you need Eclipse IDE environment where you are actually plug in some more packages also. So like you have wireless toolkits, you can plug in to that Eclipse IDE. You can download wireless toolkit. It's an optional package we discussed about. Like wireless is optional package, Bluetooth is optional package, other than the profile. Okay, any kind of emulators if you want to use, you can download it. Emulators in the last session I told you like what is emulators. You'll be emulating your hardware, like as you are running your application on your targets, like in your machines, in your mobile phones. You can actually run those applications in your software-based emulators. Like it's being designed in the software form. Like all hardware is emulated in the software. And then you can see your mobile actually, see your mobile applications running in the emulators. So for installation, once you download the J2AC SDKs, you need to verify whether that installation is fine or not. Then verify Eclipse 3.0, Eclipse 3.0 version you want to use, and then install wireless toolkit. Okay, J2ME wireless toolkit, which will provide your optional packages for wireless, and then these things you can install. Once installation is being done, you need J2ME plugin. Because you have installed, you have installed J2SC standard edition SDK software development kit, so which will not be having J2ME in itself. So you need to install J2ME plugins within the J2SC and SDKs. So you can go into this preferences of your Applets IDE, and then you can actually install your plugins, J2 plugins. Once you install J2 plugins, then only you will be able to see your midlets, your MIDP packages, your profiles. Then only you can actually create your midlet applications. So this is your wireless toolkit, optional wireless toolkit. Now, how to create your new midlet suite? How to create a project which will actually run your midlet applications? So go to the file, new project. You will see, give the name of the project, select the location of your project where you want to locate it, and then select the wireless toolkit. Also, if you want to use optional packages of wirelesses, just select those packages which you installed, and then go to toolbar, select file, new others, and you'll see how to create a new midlet. All these things you can have. This is just you can see in the slides, and you can go over with these slides one by one, and you can actually create your midlets. So application. So this is one midlet application. So for that you need to import javax.macroedition.lcd UI. LCD UI is your LCD interface. Okay, macro edition is that package we are talking about, like that package that will MIDP profile will provide. Okay, MIDP will provide this macro edition package. From there we have this LCD UI, some classes we have. We can actually go and import those classes, subclasses also, midlet subclass we can import. And then once those are, because here we are trying to display something on our LCD, so we need LCD user interface APIs. So now, so here you can see, like we are creating a class like test midlet, which is extending midlet package, and which is also implementing command listener on API. Say here. So here we are actually creating one form. New when you say new form, so form will give you that view, like where you want to display your stuff. So I want to display my name, suppose. So I will give that name in this string. This string as an argument to the form, we will give that. Okay, create a new object. Okay, new is the operator in the C++, like if you create a new one object, you create. Okay, and then once you have that object, we have created main focus as object. So by using that object, we can actually call the methods which are being provided into the in your class, like append. You want to append, append function will actually append this message, like first message will be appending. Okay, then add command. If I want to add some commands, okay, when we click on the user interface UI, that command will run, because we have already implemented command listener here. Okay, so these are the APIs which will actually take control of your life cycle of your application. First is start application. You want to start it, do start app, and then if you want to pause app, you are going to call pause app. Okay. If you want to destroy it, you just going to use destroy app. Okay. So these API, start API, pause API, and destroy app will actually start, pause, and destroy. This is just a message I'm like we are kind of printing on the LCD display. So this is what. So here you are kind of importing MIDP specific packages. So LCD UI, it's a user interface API which will provide a set of features for implementation of user interfaces for MIDP applications. Okay, and there is one class called screen class, which is a subclass of displayable. Displayable is a class, okay, that takes care of all user interactions with high-level user interface component. So you need to go and check what class I want to use. So if you want to display something, you need to include displayable class. So under that we need a screen class. If I want to display something on screen, we need also to include screen class here. So this we have already explained, like how your start application works, how your pause application works, and how your destroy application works. So this is the flow of your middle application. Any questions up to now? So there are some other APIs like get app property. You want to notify your application, use notify paused. You want to request something from a platform, use platform request, give the argument as a string here. You want to resume your void resume request. And if you want to destroy. This interface is used by applications. So there is one command listener which we actually implement. We extend, right? Command listener. This interface is used by application which need to receive high-level events from the implementation. I'm not audible to you. It seems like there is some problem with the voice there. Hello. Hello. Okay, it's clear only. Okay. Yeah. There might be some problem with your end because other colleges able to listen my voice clearly. I will be continuing with the session. So midlet content. Here is creating. Here you are actually creating your form and then adding the commands to that form. You can actually go and click those forms on your mobile. So this is how you are going to add. This is how you are actually going to add your commands. Okay, you have created objects. Then by using dot object, you are just actually calling your add commands. This will actually create another object of command class, and then we just give two arguments, exit and command.ext. And then you also need to tell that this is your this class which you want to use, like set command listener. We actually implements it. This is an example. Like we are just creating a form. So we have used here form class. A form class is a screen that contains an arbitrary mixture of items like images, read-only text fields, editable text fields, editable date fields. Okay, so that screen class will have different subclasses. It will have one subclass as a name of form. Okay, so this is what at the top level we have displayable class. Okay, displayable class, and then we have subclass as a screen and canvas. The screen will have more subclasses like list, form, alert, text box. You should know that each and every class will provide some functions, will provide some methods. Once you create the objects of that class, you can actually invoke those methods to have that functionality in your application. Okay, and all these classes is a set. All these classes are packaged in one package called .lcdui, which we are actually importing at the top. javax.microdation.lcdui. When we do, we will get all the classes. Then we can actually any of the methods within any of the class. This is how your hierarchy works. Yeah. So how to test your code? So once you're done writing your small application, midlet application, you can go ahead in your Eclipse IDE. You choose the target platform. Okay, choose target platform. What kind of platform you want to use? Desired emulators you want to run, and run your application there. Once you select, your mobile, this kind of like visual display you're going to see on your emulators if you have the emulators installed within your IDs, Eclipse ID. You can see on your mobile screen that whatever the application you're running, you have just formed one form on a screen. If you want to print your name, you can just print your name, and if you want to write some command like OK or just exit from the application, it will exit from the application. It's kind of command. You're just destroying it or kind of making it to sleep. Okay. So your once you are done making your application and you have checked in your host machine emulators, you need to distribute so that actual devices, actual targets can actually run your code. So for that, I already told you, you need to include those midlets. Like if you have created 2 or 3 midlets, you need to combine those midlets into some forms, like into some, like you can say it's a compressed form, like you say .zar z file. So that file you can actually upload on internet, and then people can download that jar files, and it will run the application to your mobile. They can download and install into their machines, into their device machine, into your mobile device, and then run the application, your application. So distribution wise, you need to include all your midlets which you have developed in your some compressed form like .zar and .zar files. This is one example. We have built a midlet as an SMS server. Okay, SMS server it will work as. So midlet listens to incoming SMS events. What happens is when we're getting some SMS events, it will check the SMS will match to the predefined pattern which we are already having. Then it will process that. Okay, we have defined a few sample commands like add a contact to the device fallback. So suppose whenever any SMS event is coming, it will process that SMS events. Okay, SMS server will process that SMS events, and then it will see whether I need to add that contact to the device phone book, or whether I need on my flash on my mobile flash backlights, or I want to make mobile in vibrating mode. So you know that when you get the SMS, your phone will be in vibrating mode, or your flash start blinking, or your automatically your contacts can be added to your phone book. All those are your features which are being provided by SMS. All those are commands which are being implemented within your midlet applications. Okay, so and you can also have one more option like a command that will order the phone to take a snapshot using a built-in camera. Okay, so it will take one command and it will take a snapshot by using built-in camera. So this is one network connectivity framework tool which they're using to do all the steps. It's a Nokia specific, okay, and NCF tool. Nokia people are using their own framework. And they will create midlets. They will run the midlets. They will run on your mobiles, and then they will create the applications. Any questions regarding J2ME? We are done with J2ME. This is the higher overview of J2ME. You can go ahead and find out some more information. You can create your applications, install. Already enabled the download option from here. I don't know why you're not able to download. So now next we are going to discuss about one more technology called Java card technology. Any questions regarding J2ME as of now? So in the next half an hour we are going to discuss Java card. We're left with any questions? Otherwise we'll go to Java card technology. Okay, I think we're going fine. So we'll be carried for the sessions like Java card technology we're discussing here. So what is Java card and what is the agenda of this particular technology? What is the agenda of this session is like we will be discussing about Java card technology and what elements we'll be considering in these applications and how we actually communicate. Here we are going to develop applets as we have developed midlets there. Midlets, we have used MIDP profile over there. That's why we are saying there midlets. The names would midlets there. Okay, that's a low end profile for CLDC configuration devices. And then Java card language limitations. So here Java card application when we create, we use for very small device like smart cards. Smart cards, your credit cards, your debit cards. These will have some integrated ICs, embedded ICs. Okay, so how that works and discuss that in this session. Okay. So what is Java card? Simple answer is like Java plus card. You are going to run Java and on your embedded card. You should have embedded IC. So it will also adopt Java platform for usage on smart cards. We are adopting Java for usage for creating applications on smart cards. Okay. So what are smart cards? A smart card is a plastic card that contains an embedded integrated IC, like your own identity card, your cell phone SIM cards, that each will have ICs. So they store and process information. Smart cards can be used to add authentication access to information systems that require high level of security. Okay, now they will have some information regarding your authentications or your security informations. Okay, so the security wise, like if something happens, if something tampered, if you're tampering your that one, so the result stored in your IC will destroy. It can destroy. Okay, it will not contain any battery and it will only active that IC will be active, which is there in your smart cards when it is connected to your card reader. Okay, so that card reader will actually give power to that circuit, to the IC circuit, which is being embedded in your cards, and then only it will work. Okay, so it comes in two forms. One is contactless and one is contact form. So this is what I mean about contact and contactless. So when you say contactless form, that means we have some kind of radio in that chip that will be continuously transmitting radio frequency signals. Okay, the range is with a typical range of less than 2 feet. So once you take that card to nearby card reader, that side will be having transmitter, and you are having radio transmitter at this side, and that side will be having receiver. So it will receive the radio frequencies. It will detect, okay, some device wants to talk to me. It will authenticate that card, and then only it will give the access for you. Okay, so that happens in case of contactless smart cards. If you are having contact smart cards, you need to contact your smart cards. Like in case of ATM, when you go in ATM, you need to contact there. If it is not contacting with the card reader, it will not detect your card. Okay. So now that we know about smart cards, what does a smart card operate? How does a smart card operate? What's the platform used for its operations? What are different mechanism elements of these smart cards are? So now we'll see what kind of applications your smart card is running. So those are called Java card applications, which will be consisting of your backend application, your host off card applications, interface devices like card readers, your on card applets, and your credentials and supporting tools. We'll see in this diagram. You can see in this diagram, like on the card side, we have one small OS, card OS. Okay, that will be embedded in your IC, your card IC. Above that, we have Java card virtual machine. because without virtual machine, you can't run your Java application at all. So that is what I was talking about in the first, that big picture Java is there, right? At the last, we have Java Card VM, which is running your Java Card applications. So here we are using those. So above Java Card virtual machine, you have Java Card framework and APIs, which you're going to actually provide to your applets. You want to create applets, you need to have some APIs which Java Card framework. Okay, so Java Card framework, Java Card virtual machine, and Card OS, all these are a part of your Java Card runtime environment, JCRE. Okay, so this Java Card runtime environment will talk to your reader side. What do you have on the reader side? On reader side, you have two stuff, like you have card acceptance device, CAD, and host applications. Okay, so host application is running on reader side, and that is communicating to your computer, main computer. Okay, your card reader will running your host application. So host application and your card acceptance device. Card acceptance device is the slot, you can say is a slot where we are actually placing your cards. Okay, reader slots and your card reader will be happening using a protocol called APDUs, like APDU protocol we're using here. There are some commands and some responses we will get in and out. Okay. Similarly, that same commands we are using between host application and that card slot where we're actually putting our card readers. You will see what kind of commands and like what is the frame of these commands and responses. So this is a big picture of how your actually Java Card application runs, how your applet runs on your card side, and what happens on your reader side, and how it is actually communicating to your main CPU. So interaction between reader and your card. So what is the functionality of your backend application systems? They will provide the security, connectivity to the security systems. Okay, so like suppose an example like electronic payment system is there. So backend application will actually provide access to the credit card and other payment informations. So now we will break down these things. So at the reader side, we have two parts. One is host application and one is your card acceptance device, as I already told. So think of a bank machine like a device is something where you are actually putting your debit cards. Any questions up to now? Any questions you can ask if you have any doubts regarding this. So on the card side, we have this frame. We have card OS, card virtual machine, and your framework APIs, and then you have your applets. So from framework to your card OS, we have JCRE. This whole environment is Java runtime card or Java card runtime environment is there. Now there are two methods by which we can actually communicate Java applets. Our main focus is on how we are actually communicating to our applets, which are running in our cards. So there are two ways. One way you can actually use message passing model. How it works, we'll explain. We'll discuss in the next slides. Message passing model, or another method is your Java card RMI invocations. The remote method invocation, as I told you, like if server have some and on your host side, on your client side, if you will take the references of those objects, you can actually call the methods within those objects, within those classes. Okay, you can just call those things. So it's like a remote method we actually invocating from our host side, from our client side. So that thing also we can do from applets, and we can also communicate through your message passing model. So this is the message passing model frame, your commands. Like command APUs, your CAD will talk to your card side using these protocols like APDU protocols. Okay. So in message passing model, we use two functions, two methods install, and one is process. So when you create your Java card applets, you need to extend class. Once you extend your extending it's just like you are importing your class so that you can access actually the functions or methods within that class. Okay, so these are implemented in this class, install and process. So once you extend that, once you import that, you are able to use that install and process methods. So what it will do actually, when you say calls install, it will install your applet. Okay, when you call process method, every time whenever there is an incoming APDU packet which is coming from your CDC, you're coming from this one CED. Okay, when in your application process happens, it will take that APDU command. Okay, it will process that APDU command. It will parse. Actually, it will parse your whole frame, and then it will see what data it is having in that frame. Okay, so APDU is a big frame. We'll see how it contains the data. So once you get the logical data packet, that exchange between your CAD and your Java card, so that APDU will be transferred through framework only. Okay, because your application, your applet is running on your framework, Java framework. So this is how your command APDU looks like. You will have headers, you will have body. So in body, you will have data field. You can see data field is there. That will actually contain your data. So when you say command APDU, some commands, whatever the command we are actually sending it out from your CAD side, that command should be located in your data field. So once you go to the applets, it will parse, it will see the headers, it will see all these options like, okay, it will parse your header, it will take the action as per whatever the response. So the response side framework is like we have two things here, body, that is data field, and one is trailer field. When we are giving the response to again the CAD side, that is your reader side, so bring the response to the reader side. So it will give the response in these two fields, SW1 and SW2, which is a part of your trailer. Okay, so what does that mean actually? When you say you're giving the response to the CAD side, that means depending upon these two bits, like depending upon these two fields, SW1 and SW2, the card reader will actually figure it out whether your process got completed when you are calling a process method, right? It got completed or it is interrupted. If it is completed, it will check whether it is completed normally or there is some warning. Okay. In the other case, if there is any interruption, whether there is any execution problem or whether there is any checking error problem, some kind of some error problems. Okay, so depending upon these two responses, SW1 and SW2, your reader side will determine whatever the response it is taking from your applet side, your card side. Any questions? Any questions regarding this, like how actually it works from your applets to your CAD, how it talks using this command APDUs and the response APDUs? Transfer the data between CAD and your card side applets. In the message passing model, how we are actually processing APDUs. When you call your process method, it will go to the Java framework. It will take first of all, when we first of all we need to do install. Install will actually take the data. Will actually take the command APDUs from the framework. This APDU method will actually parse that and will see. It will check the incoming APDUs. So JRE, that runtime environment, is actually calls your process method. The incoming APDU will passed as an argument to that process method, so that we can actually parse that command. So the applet must, what is the functionality of the applet? Now, once it gets the APDU command, it needs to parse the command APDU. Then it needs to process the data. Then it needs to generate a response APDU. It needs to again create a response APDU frame, data frame, and then it should return control to the JCRE again. That is the small functioning of your applet. It will pass the command APDU, it will process the data, and then generate the response APDU, and then it will fill those SW1 and SW2 field regarding the response of that APDU, command APDU, whether it got successfully run or whether it got some interruptions or execution problem. So once you get the response APDU generated, it will return the control to the JCRE. Then JCRE will talk to your CAD side. It will again transfer your response APDU to the CAD side at the card reader side. That is how your card reader and card side that works. Okay. So another method here, we have discussed about message passing, like message passing model within this Java card technology. Like they use APDU commands, APDU protocol. Okay. Now there is another method, that is your remote method invocation, Java card remote method invocation. Okay. So this method actually relies on a subset of model. Basically, RMI is a part of your RMI is basically part of your standard edition of Java. So when we say Java card RMI, JC RMI, it's a subset of that. Okay. So what happens in this case, like a server application is actually creating, and it will make accessible remote objects. It will create objects, and it will make that object remotely accessible. Okay. Then on your client side, what happens once it gets the reference to that object, to that remote object, it can actually invokes, by using that remote object, it can actually invokes the methods which are running there in the server side. Okay. So that is how you can actually talk to your server. So client side is actually taking the reference of the remote objects, and then it will invoke the methods using those objects on the client side, on the server side. So that is how you can actually talk to your client, talk to your server by using remote objects, remote references to the objects. So this is another method of communicating. In this case, in the case of JCRMI, Java card applet will work as a server. Okay. This will work as a server. That means it will provide your methods. It will provide all the methods. Then host application side will work as a client. If what we are running at the client is your card reader. So card reader wants to read something from your Java card applets. So your host side client needs to take some references of the remote objects. Once it will get the references to the remote objects, it will actually call your methods within the Java card applets, which are running actually on your server side, the server client terminology. Any questions? So now we've discussed about how your card reader and your card works. What are the methods in which we actually can transfer the data from your card to card reader, from your card reader to your card. So the two ways: message passing model, that is through your APDU commands, APDU protocol. Another way is RMI, remote method invocation, JCRMI, Java card RMI. So this is a little summary of Java card language. So when you want to applets, these are the features for that language. So it will provide a dynamic class loading, security manager, and then it will also provide some, you can also import some classes like java.long.security manager. And then it will also provide math threads, object cloning, all these things will provide. Okay. There's some keywords, in every language we have some defined keywords. So in here we are using native keywords: synchronized, transient, volatile, and strict FP are not. So these are actually basically the limitations when you say Java card language limitations. These things we can actually cannot use as per your Java card language. Okay, like there is no support for car, character, double, float, long. Okay, these are defined data types, right? You cannot, this is not supporting these data types, and it will not also support java.io, java.lang, utl. It will not support these things. There are some limitations of Java card language here. Other than these, it will be like you're creating your midlets. You can also create your applets, which subclass you want to use, which class you want to use, and which profile actually you want to create for your application. So create for, so you can use the methods within the classes there. I think we are done with the Java card technology. Any question regarding this Java card technology and J2ME? Any questions if you have? We have 10 minutes more. Today we are just covering this J2ME and Java card. We'll be covering some XML session is there. We'll be covering next class. Let me know if you have any questions.